So now I will be explaining for naive Bayes. So we did two algorithms for predictive data mining. The first one is decision tree and the second one is naive Bayes. So we look into it now. So first we are going to import the necessary library, the library we are going to use for this, and then we're going to select the features that we only want. So for this one, we're going to drop the columns that are not, the attributes that are not needed, like self-care, health status, and label distress. So the steps are almost the same as decision tree. It's just that we are using different classifier. So for y underscore dt is the target, so we are set the target as level distress. And then this is to split the data into train and test ratio. So we have two ratios which are 60-40 and 80-20. So for test size, we're going to put 0.4 for 60-40 and 0.2 for 80-20 ratio. And this is the ranges that are set to 0. And this is the code for naive Bayes. For naive Bayes, we use Gaussian NB. So the classifier is set to Gaussian NB, and to the trained data set is put into the classifier, and it will predict. And then we are going to import the classification report, the confusion matrix, accuracy score, and precision score from sklearn matrix. And if we execute it, this is how the classification report looks like. So this is the precision, recall, F1 score, support, and this is the confusion matrix, the performance accuracy, precision, and performance error. And for this one, we actually didn't retrieve any data set because we're going to use the same one as the decision tree one. And this is after hyperparameter tuning. So for hyperparameter tuning, we are using grid search tool. So the grid search is imported from sklearn model underscore selection, and the classifier is set to Gaussian NB, and this is the params underscore NB that we are going to use for grid search. And then this is the code, and once again we're importing the classification report, the confusion matrix, accuracy score, and others. And if you run it, this is how it looks like. And if you look at this, the performance accuracy for this one is 65.43, sorry. And after hyperparameter tuning, the performance accuracy became 67.49%. So we can see that the performance accuracy did increase after hyperparameter tuning. So now this is for 80-20 ratio and after hyperparameter tuning. And for this one, the performance accuracy is 63.79, and after hyperparameter tuning, it became 66.26%. And our second experiment is resampling and standardization. And once again, we are using the dataset in decision tree, and for this one, we are dropping the age bin because we are using standardized age, and the steps are also the same as explained before. And this is for 80-20 ratio. And this is our third experiment, which is resampling, standardization, and discretization. So for this one, we are dropping the standardized age, and we are using age bin, and this, the rest of the steps are the same. And this is all for naive Bayes in Python. Thank you.